Good morning, mathematicians. Perhaps I worried some of you that I wasn't streaming again today. But I am. No longer in front of a barn, sadly, but what can you do? Can't do math in front of a barn every day, I suppose. Well, you could. Maybe I need to organize my life in such a way that that is possible. Okay, we've got to figure out what to yap about today. I suppose I gotta get chat set up here. It's the start of a new week, start of a new semester. Although not yet. Well, I don't know about where you are, but where I am, we're about to start a new semester. I guess officially it starts next week. So I'm a free man until then. And by free, I mean I have to make some talks that I'm supposed to give next weekend. This coming weekend, I should say. And I have to relearn, brush all the cobwebs off of my Python skills. Wow, am I that late that no one's turning up in chat? Or have I made some crazy mistake where chat is people are there, but I opened up the wrong chat again? I was looking at this article this morning. Well, actually, I didn't read the article too closely yet, but I was looking at the discourse around it, and yeah, this is. Oh, hello, JR. Okay, chat is working good. I was looking at this earlier this morning, and certainly this I need to read the article. You can't just take everything from Reddit comments, but this is a concerning statement. There's some echo thing going on. That is not good. Maybe. Hopefully, there's less echo now. Is there less echo? Can I still be heard, but without an echo now? That's the question. Or have I gone completely silent? Also, Miguel with the incredibly... Okay, it's good. Great. Miguel's got the incredible profile picture. Yeah. But anyways, yeah, if true, this is a very concerning... this is not a great metric. This is not a great metric to measure mathematical production by. Also, I don't have much experience in the real world, but it seems like I can believe that this is a frequent issue in the real world is slowing things down with having to give annual meetings or weekly reports on stuff. Yikes. That would be awful. There's so much AI slop and jobs require you to use AI these days. Yeah. I guess it's seeping in everywhere. Yeah. Unfortunate. Yeah, and then they say something like made the case for accelerating math. Right. And they said by showing just how slowly math progressed between 1878 and 2018, which is like, that's insane. It's never progressed faster. Hello, Arcturus. Absolutely wild. Yeah. Yeah. Or what did they say? Scientific research, surges of innovation. Uh, yeah, like I don't know. It's just insane that like okay, yeah, those were productive periods, but like so has literally been every decade since then. I mean, I don't know. Crazy. Anywho, caught office hours. Yeah, congratulations. I guess it's because I'm streaming so late that people get to catch office hours at a different time. I should maybe do random, more random evening. I mean, evening in my time office hours. I haven't done any. Uh, am I open to random viewer questions? Yes, I'm definitely open to random viewer questions. That's what I'm here for. Arturus has been looking for a good number theory paper idea that is not nonsense. It's about the square root extended function fields, to be exact, and its combinatorial number theory of it. Well, I'm not sure of function fields. So you're adding a root to like the function field FQT. Um, well, I'm not sure. I don't know about a paper idea, but probably a good idea to, I don't know, compute. What are the automorphisms of let's say what's a better way to write it? What are the automorphisms? So I guess you're looking at this function field, and you want to adjoin a root of t to it. I guess you could try and compute maybe write f like that, and you could try and compute the automorphism group of this. Recently discovered the following result while trying to solve recurrences and recurrence-like objects generally. I guess we'll have to wait for another message for that. What do you do when math feels pointless? Let F be a vector space. P is a polynomial. T is an endomorphism of V. Okay, 1 second. So V is an F vector space. PZ is just some polynomial in F, and TZ. So I'm a little confused about the notation TZ. So yeah. I'm not sure I understand why TZ, how your endomorphism is depending on a variable. So maybe I'm just going to write it as T for now. Okay, great. Yeah. So T is an endomorphism. And then say we have PZ is some factorization to coprime factors. Then the kernel. I see. The kernel of PT is the direct sum, should be the direct sum of kernels of the PIT. Yeah, that seems reasonable to me. That seems like a reasonable statement. It definitely screams some sort of like Jordan decomposition type result. Although actually you don't even need Jordan decomposition. I think probably the proof is much more straightforward. Your questions are, can you weaken this to an R module? Most likely, yes. I would assume yes. If R is some adequately structured ring, yeah, I think that should be pretty straightforward to do. Also, you'd like to generally be able to solve for the kernels of certain factors. Yes. I mean, yeah. What is even? Do we need R to have? What kind of structure do we want? What kind of structure do we want? I guess. Does this always? How was the getaway? It was great. Thanks for asking, Sarks. It was great. Beautiful time in the mountains. Went hiking, pet horses. Didn't get to ride them. Apparently they're too rambunctious in the spring. Yeah, my guess is this should generalize just fine. I mean, maybe there's something going on because we've got this multiplication. Maybe you want it to be an integral domain. And of course, like, so number one, for sure, this is all going to hold. Good morning, Matt Miller. For sure, this is all going to hold over a principal ideal domain. Basically, anything that happens in linear algebra is still true for modules over a principal ideal domain. Yeah. Maybe I could imagine, because we're multiplying stuff here, I could imagine maybe something about integral domains breaks this. For example, if V is actually an algebra and T respects a multiplication rule, interesting, and commutativity, and V is a lambda eigenvector and a unit, then you can solve it. It seems like a lot of hypotheses. Yeah, right. So yeah, that looks like you're basically just considering a generalized eigenspaces, which I guess does bring us back to like Jordan decomposition type stuff for modules over a PID. Hello, Fimnal. I wonder, yeah, maybe if we even just break out a Luffy. Are varieties in the specific function field Arcturus, I'm gonna kick you from chat most likely, because you just keep talking about nonsense, and I hope one day that you get better and that you try and learn some mathematics, because you're obviously creative and you're interested in it, but I would encourage you to, instead of just trying to put nonsense words together that sound cool to you, try and learn some mathematics. Classification theorem. This is probably what we want. Yeah. So let R be a PID, and let M be a finitely generated module. It is entertainment, you're right, which is why I haven't kicked them from chat. But also, I I want people with legitimate mathematical questions to feel free to discuss these things here. Then the following holds. Right. But where's the I'm trying to remember. There's some finitely generated is sort of a problem in your cases. Frequently you need infinite dimensional. I see. I see. Yeah, that could make things more difficult. I mean, one direction should be easy, right? Like there should be an injection. There should be an injection in one direction in general, right? Like that should be pretty straightforward, I would think. For example, f to the n smooth functions over c. Right, I see you've got this direction. And I guess you're thinking of the... so what? I guess you're struggling to prove surjectivity in certain cases? Why would that be the case? So say V is in the kernel of PT. Why do I keep writing on an angle like this? So PT at V is 0. I mean, if the polynomial factors, right? I mean, if the polynomial factors, it should just be like, it should just factor as this product, right? Am I being silly? Am I being too glib? Do I need to be more rigorous with this part of the proof? Kaplansky, we share a philosophy about linear algebra. We think basis free. We write basis free. But when the chips are down, we close the office door and we compute with matrices like fury. Yes, true. Except your basis god can't save you now, because we're dealing with arbitrary modules at the moment. So not even your precious of axiom of choice can save you now. Right. So I think all we really need, right? What do we need here? I mean, I mean, if R is an integral. Oh wait, no. This is what am I saying? This is a map. This is a map of vector spaces. But you want V to have an algebra structure. Fimnal has a question. Had a question earlier today. But you forgot it. Had to do with profinite groups. As your algebra professor, let us do some infinite Galois theory. Nice. But here we're looking at an algebra of endomorphisms. Right. Oh, I guess what... so sorry, what is this? This is... Right. This should be what? The composition? Yeah. Yeah, we don't think that has an integral domain property. Right. Well, I mean, it is... I mean, it's still a ring, right? So you can definitely still think about okay, let's go back a second here. Wait, is it composition? I mean, suppose or do we get some factorization property, yeah, what's the relation between these things? Because OneNote's freezing up again. Wow, it's really taking its sweet time. Sorry, gang. I'm gonna have to get a new writing system or something. But I like OneNote. Okay. Right. So T is here. P factors. I think we'd somehow need independence of the images and kernels between the elements of the product. Yeah, I guess if you want a direct sum, that's probably not going to be true in general. Not independence, disjointness. Yeah. You just want them to like intersect in the zero vector or something. I see. Sounds like fun. You wish you were in that class. You're interested in profinite groups? Cool. Grothendieck-Teichmüller groups. Oh, yeah. Someone pointed out in a comment, actually, I mistyped something the other day. I did accidentally Grothendieck and then dash with the minus Teichmüller, which removes, apparently, Teichmüller from the search, when in fact I wanted it to be like this, and that's why it didn't bring up the correct thing. Here we go. Now we have it. But I think the answer, the person who commented says I was right anyways in my suspicion that they were unrelated. So Journal Plus is pretty good, but as a Linux user, you have low standards. Okay. I guess I have low standards too, though, because I don't even... Well, do I? I don't know. My standards are OneNote, so is that low or high? Probably low. In mathematics, the GT Grothendieck-Teichmüller group is closely related to absolute Galois group. I see. Yeah, I don't think this has anything to do with the Grothendieck group of a commutative monoid. Yeah. But coming back to this thing, so how do we even see the Ford's direction, right? So suppose V was in the kernel of suppose it was in the kernel of PIT. Thus, yeah. So is it true? Is it true that if this polynomial factors like this becomes the composition? Oh, maybe that is true. Okay, maybe that is true. That does make sense now, actually. Right. Right. Right, so if we're going back to here, wiki page kind of doesn't respect its true beauty. Probably. Yeah, I should have gone to NLab. You have a proof for the vector space case. Can't do it from modules so far, but also can't come up with a counterexample. How does it work in the vector space case? Did you pick a basis? Is that part of what happens? Like what's going wrong? What do you do in the vector space case that you aren't able to do in the module case? Let's go see NLab. Grothendieck-Teichmüller, tower, construction, moduli spaces. Aha. I'll give you 1 minute to think the notes are written on your other operating system. Yeah, no worries. Take your time, take your time. Grothendieck-Teichmüller Lie algebra. You have a question now. Your professor once stated Baer's criterion in a little bit of a different way, and our module is injective. If and only if for every ideal, the module homomorphism I to M is of the form FRRM for some fixed M and M. Right. I vaguely recall using this at some point in my algebra course. You see one implication, but the reverse one is not obvious to you, or that it should be true. Yeah, I don't remember Baer's criterion being obvious. Baer criterion modules proof. Oh, sketch of a proof right here on NLab. This, well, mind you, this is an NLab proof, but this looks shorter than I expected. For some reason, I remembered Baer's criterion being longer. Oh, you proved both already? Wait, so what was your question? How did I study for quals? And how hard, easy was it? You're familiar with most of the topics, but I feel you'll stumble if you see an exercise. Yeah, the thing is, quals at my university are kind of weird. You had to do like 3 exams, but they were like tied to courses. So basically, if you took one of the courses, you had to tell the instructor early on that you wanted it to count as a qual, and then you would be given a special exam, and that exam would get like reviewed by a committee, and then you would write that exam in place of the final exam. That other people not doing it for quals would have done. I didn't think it was that hard, but you know, I know other places like I know people at other places that have like brutal quals that are like, you know, 6 hours exam with like everything at once. Yeah, I don't know, I studied the way I always study. I do lots of exercises, I memorized a bunch of stuff, I made flashcards, know all my definitions, know all my major proofs of theorems, stuff like that. You proved both, but you don't see how the 2 versions should be equivalent. Well, I don't know what to say. If you got the proof, you got the proof. I mean, of course, going through the proof is different than understanding all the details. But yeah, I mean, it's been a while since I've touched this, so I don't know if I can give you a better intuitive description of why it ought to be true, unfortunately. There's a suspicion that the GT group might be related to Monster Moonshine. You don't know the details. Interesting. Interesting, yeah. I mean, okay, just vaguely, Moonshine has something to do with the J function, which is some function on a moduli space of elliptic curves, and the Grothendieck-Teichmüller group, based off what I just read, has something to do with moduli spaces of genus G curves. So sure, I don't know. It seems plausible. So 2 parts of your proof. First of all, we should be able to proceed inductively, split off that, and then decompose the second term. Sure. Yeah, that makes sense. or two factors. So for two factors, write P as a product with F and G co-prime. Right, we needed that theorem. Use Chinese remainder theorem to write that. Right. And then use critical race theory to show existence and uniqueness. And this can be done constructively. Right. Okay, I'm with you so far. Right, I'm with you so far. So in the two-factor case, P is F times G, and we've cooked up some F and G which solve some X and Y which solve this. We can cook up some explicit ones. Right, but I guess here we're using facts. We're using things about F being a field, right? We're definitely using things about F being a field. So what do we need? What do we need in order to make sense of this more generally? Well, I don't know. Desan, don't take my explanation. I totally just pulled that out of my butt after staring at the NLab page for like 3 seconds. So I was just saying random stuff, man. Don't take my. It could be way more complicated than what I just said. But at a quick glance, that was what I thought could be the case. So. But I'm not so sure about P equals Fx plus Gy. I mean, I believe the Fx plus Gy equals 1, but I don't know why. Maybe the P equals is also a typo there. Right. If F. So we need Fz to be a principal ideal domain. Good morning, Nerd Coke. So yeah, principal ideal domain, coprime if and only if comaximal. Nice for the critical race theorem. Yeah. Right. You're right. Oh, 2 a.m. Well, then you're doing great. Very minimal typos for 2 a.m. Very minimal typos for 2 a.m. Right. Okay, I see. So we really need FZ. So that's really the key here. We need this to be a PID. Yeah. So then what if we have when is R X a PID? Oh, really? It's equivalent? Damn. Okay. So never mind the module case then. I mean, you're basically forced into okay, never mind. Like I see. This is the part where the field assumption is critical and you want to weaken it. Right. I see. Okay, I'm starting to understand now. So how do we avoid a principal ideal domain proof of this fact? I mean, the thing to start, the thing to think about then is maybe take like what's the simplest non-PID you can think of, and can you cook up a counterexample? That would be the very first thing that I would check now. So what is it? What's that classic example? Is it Z root 5? Is that the one that's everyone's first PID? I think like 6 has 2 factorizations, or something like. No, this is for failure of UFD. What's everyone's favorite non-PID example? It's this, right? Or am I crazy? I should know this. I'm supposed to be an algebra pro. Oh, minus 5. That's what it is. Minus 5. Isn't that quite severe? UFD is weaker than PID. Yeah, I mean PID implies UFD, but yeah. Yeah, non-UFD. Right, but also yeah. I mean, just you're right, Fimnal. But then the thing to do is like check it here. Let's say it fails here, and then you could say, "Oh, well, maybe the thing that made it fail is rather not the PID part, but the UFD part." Yeah. So then if you can cook it up to fail there. Yeah, so try and take like, I don't know, take this, maybe take like a rank 2 module. Well, mind you, I mean, if it's gonna fail, you probably don't want a free module either, right? You probably like, yeah, because there could be other. Well, maybe start with a free module, right? Start with the easiest things. You actually at least need a UFD with an infinite number of maximal ideals. Is that true? Why is that true? Why would you need an infinite number of maximal ideals? Because like the proof works for vector spaces, so it should work over finite fields, right? Semi-local UFD might be onto something, but maybe the approach is just to take a ring, which is a PID, and then to join a variable. Recall what we need is FZ to fail to be a PID, not F as a PID. That's true, actually. Yeah, that's true. That's true. Yeah, I mean, certainly, I really do believe, like, I really do believe that it should still be true if F is a PID. That's what my intuition tells me. Suji, we are talking about a random viewer question, digging into random stuff about well, what is our setup? We've got an F vector space V. We've got an F vector space V. We've got some polynomial with coefficients in that vector space that factors into n polynomials. I think we want them to be pairwise co-prime. And we've got a linear transformation, an endomorphism of that vector space. And then the question is, so we get the linear transformation P evaluated at T. And when is the kernel of that decomposed as a direct sum of the kernels of the individual factors? I've attracted too many algebraicists to the live. Yeah. Yeah, I need, I need more analysis friends, but I'm kind of an algebraicist, so I don't know. I talked about some p-adic analysis the other day. Are you not satisfied with p-adic analysis and how it's and how wonderful it is? Wonderful and chaotic. The original beautiful consequence of this theorem, for context, by the way, if you have a linear recurrence relation with characteristic polynomial P, then the solution space is a vector space. Fimnal is actually a topologist at heart. Well, we like topology here too. Math mage likes algebra. That's good. That's good. But I want, I want to have a live stream where we can all get along, except for people who believe in axiom of choice. I'm kidding. I use it daily, but I have my reservations. The solution space is a direct sum of the solution spaces to the corresponding linear recurrences represented by the factor characteristic polynomials. Yeah, that makes sense. I guess it becomes Right. Maybe easier to sort of build up the solutions from these individual terms. Yeah. Hello again, Arcturus. Yeah. Okay. Well, what else to yap about? The same is true for differential equations. So like when you use if you're writing this for a characteristic polynomial of a differential equations, here we go. This is what I'm talking about. Marriage of analysis and algebra. This is what I'm here for. Let's go. Let's go. Obviously believe in the... Yes, of course. Yes, axiom of choice is true. Well ordering is false. And who can say about Zorn's lemma? Well, Arcturus, you don't have to talk about anything. But I would encourage you to talk about things. I just recommend, maybe starting with a very basic book on like discrete mathematics. Just a basic book on how to prove things. Something like Polya's How to Prove It. Just start there, nice and simple. Try proving some very basic things about set theory. You gotta walk before you can run. You're an analyst at heart. Love analytic number theory. Ever dipped your toes? Sort of. I mean, yeah. Or Basic Math by Serge Lang. Try that one too. Have I ever dipped my toes into algebra, analytic number theory? Not really. I mean, my preprint says the word, talks about the word L functions sometimes, but these are also local L functions, which is basically just some like rational function in P to the S, pretty much. Yeah, and of course there's like in played around very, very minimally with like the Dedekind zeta function. When I was doing some like algebraic number theory in an algebraic number theory course, but of course naturally it leads into things like the Dedekind zeta function. And I mean there's like automorphic forms type stuff, which is related to my research, but I don't, I'd like to understand it better. Well, Arcturus, you say you can prove stuff very well, but, I haven't seen any evidence of that fact. So I would, again, encourage you, start with some very, very basic statements in mathematics, and see if you can write a formal proof. Like, here we go. Send me your proof. Construct an explicit bijection between the set of functions from A cross B to C, and what is it? What's the other set? So the set of functions from the Cartesian product of A and B into C to the set of functions from A into the functions. Which way do I write it? From B, let me write it this way. From the functions, the set of functions from B into C. Right? So maybe HOM, one way you could write it is HOM ABC. Write down the explicit bijections and prove it's a bijection from here. And email me your proof of this. Make the nicest proof you can. And I'll even this time, this one time, I'll review it, I'll look it over, and I'll tell you what I think, free of charge. It is not the tensor HOM adjunction. This is just a statement about sets, but okay, this is certainly related, and there is some sort of a junction going on. But yeah, so that's my challenge to you. If to see if you actually prove well. See if you can write me up a nice proof of that fact. Nice rigorous proof of that fact. Where are we in the questions here? Don't know enough about algebraic number theory, trying to learn more. It's so cool. It is so cool. Do I know about Bayes' basic number theory? If not, look at the table of contents. I think I've looked at this before, and it's crazy, right? Yeah, I mean, basic is a relative concept, right? Yeah, locally compact fields, lattices and duality, places of A fields, Adels. Very cool stuff. Ooh, class field theory. I mean, in the face of modern language, I guess it's basic. Modern Langlands. Wrote a comment that got filtered for quartz language about basic number theory. Good. I have to imagine that there's better places to understand class field theory and art and reciprocity in the modern era. There's probably more streamlined expositions in the modern day. Are there people here doing algebraic geometry? Definitely. I mean, I do some algebraic geometry, and I know for a fact that some of my regular viewers are doing algebraic geometry too. What's my advice for first-generation students looking at getting into grad school with no money? Well, I have a ton of debt from student loans, so that's what I did. Can I recommend it? I don't know if I'd recommend it. But then what else are you going to do? Like go work for 10 years first to be able to afford school? You know what you could do? You could go into some sort of lucrative applied math field, take out a bunch of loans, but then like pay them off a year or two after you graduate because, you know, you'll have a real job that makes real money. That is a possibility. You do get a stipend in grad school, but it's not a lot. Yeah, that's what I did. That's what I did. And I'm very lucky because how it works here in Canada is I don't have to pay, or at least from my province, at least at the time I took out my loans, I don't pay any interest or have to make payments until I stop being a student. So I could technically just be a student forever and never have to pay them back. But I don't want to do that. Use Castles and Froelich. Algebraic number theory pretty much covers everything. That is true. When you said Dedekind zeta functions, you remembered a key definition on that exact thing. Good. You're talking about Neukirch, which Fimnel recommended. Yeah. Oh, yeah. Neukirch. Yeah, you should. It's a good book. Yeah. I haven't read it to cover, but I've used it, and it's nice. Your plan was to work, but it's impossible to find a job currently. Yeah. That's tricky then. I'm not sure what to say. Yeah, for grad school, the thing is it shouldn't cost you any money. It shouldn't cost you any money to go to grad school. Like, there's the structure where I am is awful because it's like we have very low pay and then we have to pay tuition on top of it. So tuition isn't waived, but yeah. In theory, wherever you go, though, they should be giving you enough money to survive, even if that's on very cheap groceries and in a terrible apartment with like 3 roommates. But you should have enough money to survive. It shouldn't cost you money to go to grad school. And if any grad school accepts you, but makes you pay on your own, then you didn't actually get accepted. That's what that means. Coming from Europe, you'd say you should pay. I'm assuming that should not pay for any higher education. Yeah, shouldn't. Yeah, I mean that's true. That's true even in like North America. You should not pay for higher education. Not in mathematics, anyways. Job market is tricky. Software engineering is still pretty soft for math grads with decent combinatoric skills. Interview questions are just medium difficulty, discrete, and combinatorics. Good to know. Good to keep in mind. Speaking of, I have a week to brush the cobwebs off Python and write a couple talks. Less than a week now, actually. So I think it's time to hit the gym and then hit the books. And by the books, I mean opening VS Code. So that's going to do it for today. Thanks, everyone, for joining me as usual. Probably see some of you tomorrow morning, but odds are I'll be back to an earlier time then. What am I doing in Python? I'm taking some course that helps give abstraction-pilled people like myself tools to transition to industry. But you need a certain level of sufficiency of Python to even participate. And I just want to, get back in the groove, I was able to answer the basic questions, where competency questions on the application form. But, high school math student who has just begun studying real analysis and Dedekind cuts and Euclidean space. Any good advice for your math journey? Well, I don't know what to say in general. Just I don't know. Keep going. Do lots of exercises. Keep writing proofs. That's great that you're working on it. I would say study Cauchy sequences too, because I feel like they're superior, but that's my personal taste. Keep at it and keep connecting with people online to help you along on your journey. That's the broad advice I could give you now. And every time you come across a new definition, commit to memory both an example and a counterexample of something that satisfies that definition. That's very important. Okay. Anyways, I'm gonna take off now. Hopefully I'll see you all soon, and go prove some theorems.